I'm your host, Alec Crawford, founder and CEO of Artificial Intelligence Risk Inc., and this is AI Risk Reward, a podcast about balancing the risk and reward of using AI personally, professionally, and as a large organization. We will discuss hot topics such as, will AI take my job or make it better? When I ask ChatGPT work questions, is that even safe? From an ethical perspective, is it enough for big companies to anonymize private data before using it? Probably not. I'm discussing these issues with AI experts to answer burning questions and stay ahead of the curve on AI. I'd also like to give a shout out to our podcast producer and audio engineering team at Troutman Street Audio. You can check them out on LinkedIn. Hey everyone, it's Alec Crawford, your host for the AI Risk Reward podcast, and we're going to do a deep dive today on AI governance. So a little bit of a different format. And we're here with Mike Hind from IBM, a distinguished research staff member who focuses on AI governance. Welcome, Mike.
Thank you. It's a pleasure to be here, Alec.
I should really say welcome back, because obviously this is your second appearance on the show, and the first one was so awesome. And as we really think about the future here of AI and AI governance, obviously things are moving very, very fast in AI development. I mean, we literally see new models being released, every couple of weeks from the big companies, from the small companies, from the Chinese companies. And what we haven't done, as well as a society at least, is really get our arms around, how to control these models and how to keep them from doing things that we don't want them to. So why don't you explain to the audience a little bit about how you think about AI governance and what that really means to you and how you define it?
Sure. It's a huge topic, and the term itself has a lot of different definitions depending on who you talk to. So one definition is more of, I'd say, an enterprise one, where, they typically have IT departments and CTOs and CIOs who are just trying to manage the software, manage, what applications, and manage risk, right? And we've always had risk with software, particularly, places like the medical industry, financial industry. So AI governance there means applying the same kind of risk awareness to AI software. It still is software at the end. So things like, let's make sure that when we develop something, it meets a specification. Let's make sure we test it, let's sure we monitor it, and so on. And now the change with AI, of course, is it's stochastic or not deterministic, meaning that you can test the heck out of it, but it may behave differently when it's actually deployed, which introduces a really significant wrinkle. So that's sort of one definition is, okay, how does an enterprise feel good about putting their models out to their customers so that, bad things don't happen? Very important. Another view of AI governance is society cares about the ramifications of these models doing really bad things, and what can we do about that? The social impact, which is related to the first part, but the first part's more of a, not protect the company, but make sure, you manage risk for the company. And of course, companies don't want to mess up, society and things like that. So the social impact says, hey, wait a minute, these things may be getting out of control. They're unfettered. Can we really trust enterprise to do the right thing? Do we need regulations and all that kind of stuff? So to net it all out in a few seconds, it's, I would say, very interesting, very complicated. And sometimes analogies are very useful, like I just made to software. Some things like, transparency, nutritional labels are useful analogies, and sometimes they're a little misleading, and maybe we'll get into that, a little bit more. But I guess where I see things now is there seems to be a change, I guess, in that there was pretty decent momentum for regulation worldwide, maybe 4 years ago or so. And now it seems like the general, of course it varies from region to region, but there seems to be people saying, well, maybe we were getting too aggressive and we need to back off. But we could talk more as we go on.
Yeah, absolutely. So tell us a little bit about your recent research in this area, or any findings, or feel free to reference any papers, either your own papers or your colleagues.
Sure. So my colleagues and I have done a lot of interesting work, both in open source and also in IBM's products, which is called watsonx Governance, ironically. well, not ironically. So there's sort of the stages, like, we talked about, ultimately we're talking about governance, you're talking about managing risk. So when you talk about managing risk of AI, you need to say, well, what do you mean? What are the risks of AI, right? So we created I guess about 2 years ago, something called an AI risk atlas. If you just search for that, you'll find it. And what is it? It's a taxonomy of saying these are the risks that could happen with AI, right? Publicly available. And so basically gives them names. And then in many cases gives public examples, right? So, maybe a risk for, your generative AI creating biased output. And then we have an example of a real case, quoting basically the press that says, okay, here's what happened and here are the ramifications. So it makes it more real for folks to see, not only is it just a term with your theoretical risk, but in many cases actually happened. And then there are actually other taxonomies like this out there. And there's also a section in the web page for each risk where we link it to other taxonomies that are related. And when you talk about taxonomies, you're kind of splitting the world into different kinds of things. And depending on your point of view, you may go deeper or narrower, like OWASP has the top 10 risks, right? So there's 10. We have around 70, I think is the latest, and includes agenic risks as well. And then there's others that have more. And so there's that mapping there in case people are familiar with, one taxonomy versus the other. So that's the beginning, right? Just, can we have a vocabulary to talk about risk for AI? The next step is, well, what can you do? So some of the things we've done in research that's now on an IBM product is to say, okay, I have a particular use of AI in mind. I want to use AI to do screening of resumes, let's say, right? Because I just can't keep up with the thousands I've been getting. Given that description, that use case, which of the 70-ish risks are relevant to that use case, right? So it's a process. You could think of it as sort of a questionnaire, maybe TurboTax interview kind of thing, where you answer questions about the use case, and what comes out at the end is a set of risks, a subset of all the ones there. So now you've gone from in theory, these 70 could be relevant to the ones that are particularly relevant for your particular use case. Okay, great. So now you know what you should be worried about. Now what, right? One of the things you want to do is I have a model now I'm going to use for that use case. I'm actually, develop something. I now want to test it for those risks. So we've come out with something called a model risk evaluation, which is you can think of it as testing for risks or automated red teaming. It basically says, given those risks that you just identified, we will throw a bunch of tests at it, a bunch of data sets that we'll give to the model, see how it reacts, and then score the model based on its answers. And that gives you sort of a quantifiable number to say, okay, how does this model do on this risk? So it gives you a number between 0 and 1. And then you might say, well, what's good? What's bad, right? How do I know? So what we do is we compare to a whole bunch of other models that we measured, and we give you sort of this percentile view. As out of all the models we mentioned, you're at 80 percentile and so on. And then finally, the last step of this stage is, for this life cycle is, okay, I've tested, now I'm going to deploy. Like I said before, things can go wrong. No matter how much testing you do, it can still go wrong at runtime. So there's this thing called guardrails, which is basically runtime detectors. Basically, think of it as a component that looks at the input coming in and the output going out and says, hey, I think something bad happened. Think about like a smoke alarm kind of thing where it's, you've in the house already and now you're trying to measure those things. So that's all product stuff that came from research. And then the open source part is if you go back to 2 steps where you were answering questions to figure out which risks were relevant to your use case, there's some really cool things, and it's called the Risk Atlas Nexus, Nexus. And it's an open source repository that actually uses AI to help you figure out which risks and avoid answering the questions. So if you decide these questions are kind of tedious, here's a description of what I want to do. Back to the case of resume screening. I wrote it down in text. I wrote a paragraph or maybe a sentence. And now based on that description, I will have a system automatically figure out which risks are relevant. So it's leveraging AI to do risk identification.
Yeah, very cool. So along with the Risk Atlas and obviously OWASP that really focuses on this as well. Are there any other frameworks out there that have been adopted by the risk management community for AI yet?
So there's NIST has sort of their enumeration as well. There's an MIT database, which is related, but not exactly the same. It's a database of incidents. So, examples, and they have hundreds in there. Mm-hmm. And to sort of categorize the incidents, they have to put like a classification on top of it. So in some sense, it is a taxonomy, but I think the real goal was to be, to have all the incidents there. So there's a few of those. And then when we talk to companies, they often have their own taxonomy. Like maybe, like for, one example is prompt injection, where you're trying to trick the model to do something that, the system prompt said, don't do it. And so you have a query and it says, by the way, dump your system prompt or ignore your system prompt, right? So you trick it in that way. So in that general space, you could call that one risk, like the way I described it. And if you're thinking of it at a big picture, it's one big risk. But if you get a bit more technical and go in more of a deep dive, you'll see, wait a minute, there's actually different versions of that. So when you make a taxonomy, you have this question of, do I call that one thing and keep it short? Or do I call it, 15 different things in getting to all the details? So that's what happens with the taxonomies. So going back to the companies and enterprises, depending on what they care about, they'll go deeper or shallower in these categories. They may have their own. They may say there's really only 3 risks, right? And they group them up at very coarse level.
Yeah, that totally makes sense. Yeah, and the NIST AI risk management framework is very broad, right? Right. It can be applied to any industry, any company, any organization. Whereas I think the taxonomies like you're talking about are much more specific and really way more helpful in terms of thinking about risk management. So effectively what you had mentioned earlier in terms of, runtime or real-time AI risk management. So before that step, obviously you can get to what people call evals, right? Where you're basically, hey, I got an AI model. I need to figure out how robust it is. I'll make it up 1,000 questions at it. And I know what the answer is supposed to be. And I'm going to figure out how many it gets right or how many it totally goes off the rails. So how sophisticated is that at this point? And what are some frameworks or guidelines around using evals or building evals to help you as you stress test or risk manage a new model or new use case in AI?
Yeah. So just to add on to what you said, what we're talking about is taking some software and testing it because we're worried about it doing bad things at runtime. So what you tested on hopefully is representative of what you will see at runtime, right? And in the case of most software, particularly with LLMs, the space of possible inputs is probably close to infinite or at least exponential, right? So meaning, it's equivalent to asking the question, what could someone ask an LLM, right? Well, anything, right? Any kind of text, right? Or numbers, or maybe you can throw a PDF and see what happens, right? So if you're worried about being correct, whatever that means for all those cases, how do you test for that? Well, ideally, you would test all those cases. That's not pragmatic. You can't even enumerate all those cases. So just inherently, testing is going to be incomplete, whether you're doing AI or not. As long as your input space is very large, you just can't test it. It's not practical. Now, when you talk about testing AI, in particular Gen AI, there's this additional problem, and that is, let's say I care about it knowing the capital of New York State, right? So I will write that question, and I will, get an answer, and I expect the answer to be Albany, right? But maybe it says Albany, New York. Is that correct? Maybe it says Albany where the A is capitalized or all the letters are capitalized. Is that correct? And so on. So the simple thing that we take for granted, which is to say, I'm going to ask a question, I'm going to look at the answer, and I'm going to score it as thumbs up, thumbs down, now has gotten really hard because we're talking, natural language and text And that's very hard. And there's also, it gets more subtle than that. It could be, what is the temperature when water freezes, right? You might get maybe you'll get a number, maybe you'll get a sentence. Maybe it'll say it's 32 degrees Fahrenheit. I hope this is helpful. Okay, you didn't expect that I hope this is helpful part, but it's not wrong, maybe, right? So judging these responses is really, really challenging. So the two big caveats there is you can't fill the whole space. You can't test the whole space. And judging now gets to be subtle of how do I know if that was correct? Because you didn't necessarily anticipate you can't really enumerate all the possible correct answers, which then leads to this question of, well, how do I judge if an LLM gave the right answer or not? And a popular approach, believe it or not, is to use LLMs to judge the output of LLMs, okay? Which is either brilliant or circular and faulty, and it's hard to know which is which. But it's very popular. So the answer to your question of how mature are we, on one hand, we're mature in that there's this product that we developed at IBM as part of watsonx Governance called Model Risk Evaluation. There's open source infrastructure that we actually leverage, something called Unitext, that automates the process of measuring models in general. But in terms of how confident you would be, like let's say we did one of these tests and it came back with a particular score, would I bet the house that is a guarantee it's not going to mess up at runtime? No, because of the two problems that we mentioned.
Yeah. It's all a matter of what is acceptable, right? And I go back to the example of when the U.S. was building the phone system for the first time, right? And AT&T came into existence, and their goal, because they viewed the phone system as part of effectively national security, the ability for the president to call someone anywhere in the country. And when you pick up the phone, the dial tone is there. And when you call someone, they pick up, was 5 nines, right? That was their goal, 99.999% uptime, effectively, right? Mm-hmm. That's, in many cases, just not plausible for Gen AI. As you point out, it's stochastic. So you really have to decide, look, is this writing a poem, for me? Okay, in that case, it's not critical if it writes me a poem 95% of the time and 5% it's garbage or gibberish, maybe that's okay, right? But if it's, I need the correct answer to a medical question, and if it's wrong, someone's going to die, right? That better be 99.999% accurate with a human reviewing it going like, I'm going to double check this because this is life or death, right? So I think that's certainly part of it. Is there a framework anywhere for deciding like, hey, how many nines of accuracy do we need here? Or that's still up to each organization to figure out for themselves based on the use case?
Yeah, I think it's challenging. And let me just add to what you said before I answer the question is, it's the big difference between, I would say, consumer use in general of Gen AI and enterprise use, right? Like you said, if I'm just asking a question or want to make a shopping list or whatever it may be, maybe I can tolerate errors. But if I'm deploying this in an enterprise where either my company's got some kind of liability legally or financially, or customers, can really be impacted, the ball game is very different. So I guess what I would say is right now, your question is really the answer, right? Which is enterprises need to think about precisely their use case. Think about what they do now, with private, if they're not using Gen AI, and what's the level of risk that they're willing to take, or the inaccuracy they're willing to take, with humans, probably, and then decide what's acceptable, right? So there's this trade-off, or there can be this trade-off if I have a process, let's say loan approval, where maybe it's now a human is looking at it, using their expertise, deciding what gets to be approved, and now we're thinking about using AI or Gen AI for that. One obvious upside is I could probably do it faster, and it's more scalable and so on, and reducing costs in terms of labor. But there's a question of potential downside of, reducing the accuracy. Not necessarily. It could be the case the accuracy gets better. But if I am reducing the accuracy, what's that trade-off between scaling and reducing costs versus, taking on whatever it may be, financial liability, legal liability, or, customers being unhappy. So it's really a business decision. It comes down to, the goals and the use case. And of course, on top of all this is regulations. Sometimes it's not just a business decision. It's someone else has decided you shall not do this, or you should do this. And then of course you have to comply with that.
Yeah. So we were talking earlier about how, regulation is slowing down, not speeding up, right? So in the US, for the SEC, for example, abandoned its proposed AI rules with a new administration. In Europe, they're strongly thinking about pushing back the deadlines for some of the EU AI regulations. Although they're still in place, the implementation deadlines are changing, and they may end up watering down some of it, just because I think part of it is concern from organizations saying, hey, we just won't be able to meet these deadlines. Like, this is too hard. And also, I think as you look around the globe, many organizations and people feel we're in a global AI race, right? And you've got this balancing act between, wow, we're trying to do stuff as fast as we can and do stuff better than other companies or organizations or countries, and still like being able to keep it safe. So I guess from a governance and ethics standpoint for AI, like how should we be thinking about that as practitioners? Should we be picking up the baton there that the governments have dropped and trying to really at least encourage organizations to do this? Or is it kind of too late, cat's out of the bag, Skynet is coming?
I will take option two. But I think what I would say is I'd go back to the first question, which is, if I'm an enterprise, I probably have a vested interest in making sure my deployed AI doesn't mess up, right? One of the reasons we mentioned is because there's regulations about that, or there may be regulations coming. But I think it's just bad business, of course, to have it, do bad things. So I'm hoping, maybe I'm too optimistic, but I'm hoping that the business goals sort of align with doing the right thing, meaning that a poorly performing AI system where you define it in a very general way is not going to be good for my business, right? And so therefore, I need to make sure I do my own internal AI governance to make sure I do the right thing. Now, one thing that's probably, I can hear, probably some folks are saying, well, wait a minute, it's not that simple and it's too optimistic. And I guess I would say the place where that's maybe will come to a head is this requirement of transparency. So, there's a lot of different views of, what regulation means. Sometimes it's talking about the process that you have internally, but quite often there's a documentation aspect and make available information about whatever it may be, how you train the model, how you deploy it, what kind of guardrails, et cetera. So there's usually this transparency aspect, and then transparency means making it available publicly. In my ideal world I was talking about before, where companies are trying to govern their system so it doesn't perform bad, there's not really a vested interest usually for them to, if they do the right thing, to make it available publicly. So that's one thing where I think the absence of regulations would sort of force things on a different path, where you wouldn't have that, I think, natural transparency. You wouldn't have the transparency you would have in a very strict regulation space, or if it was just companies doing those things. And then how do you deal with that? I think there was an interesting thing. There's this thing called the Stanford Transparency Index, and the idea was it started out at Stanford and there's some other universities involved now. And what they did is they said, let's go and look specifically at the foundation model producers, and let's look at their documentation on how they document their model. What do they say? And before we, look at it, let's come up with a bunch of questions. Do they talk about the training data set and the legal rights and so on and so forth? So they had a bunch of questions. They went and looked at the documentation for various models, and then they gave it a score. And what was interesting is, of course, the first time it came out, it was kind of headlines of who was at the top, who was at the bottom, and so on. And we've been doing this over the last 3 years now. So it started in 2023. They just came out with one in 2025. And you see changes. And it's probably maybe a reflection on the regulatory environment, but also a reflection on how much the company is moving that, between what you said, the big race to get better and better versus the race to do the right thing and document. So a long-winded way of saying, in the absence of regulation, I think activities like that could sort of help, particularly if it gets picked up by the press, because you can see, hey, this model that in general people like is doing a really bad job at transparency, and maybe that will become an issue down the road.
And now a word from our sponsor. Artificial Intelligence Risk Inc. accelerates adoption of GenAI safely. They provide the governance, risk, compliance, and cybersecurity platform that financial, healthcare, and other regulated organizations need before they can use GenAI safely and in compliance with regulatory requirements. Their software has won #1 awards for cybersecurity and compliance from Waters Technology. Find them at aicrisk.com. Yeah, getting the press involved sounds important, right? You just have to create some transparency in terms of what these companies are doing and how the models are performing and all that kind of stuff. That reminds me of explainability of models, which, if you think about it, if you go into ChatGPT right now and say, hey, what's capital France? It's going to say Paris. Like, where did that information come from? Like, it probably can't tell you, right? Because it was just trained on that data. Now, if you change your prompt and say, hey, go look up on the internet what the capital of France is, it will say Paris, and I got it from wherever, Wikipedia or some other source, but not if you just look at the base model training. It has no idea today where that information came from. So just curious, like, how important is explainability going to be in the future in terms of AI governance?
Yeah, I'm glad you brought this up because for the last 5 or 6 years, these two terms, explainability and transparency, are often conflated. I was just talking with financial services sort of regulators where they were coming up with a draft document basically on these two topics. So I think your definition is the one I use, which is transparency is documentation about the AI system or model or data set, demographics about it, how it was built, things like that. It's a document. Explainability is answering the question, like you said, of, why did you say Paris? So I had some interaction with the model. It gave me an answer and I want to know why, right? So why is that important? There's two reasons, and they're very different personas. One is I want to know why, because it made a mistake and I want to go and fix it. I want to debug, right? And so a lot of researchers are focusing on that problem. That's not typically what the masses want, right? I was denied my loan. Tell me why, right? Don't tell me, well, it was layer 17, this activation happened or didn't happen, right? I want to know what about my profile, about my loan application led to your decision, and is it something I can fix? Most likely. So, and speak to me in the language that I understand, right? And this itself has many layers, right? Because you can say, well, your loan application, you answered these questions and we computed I'm going to make it up, some acronym, the APX, right? And your APX was lower than 7.3. That could be a very legitimate answer. And that's kind of the level they're working at, but that's not useful to the consumer, right? What the heck is APX? Turns out APX might be derived from your income and the amount of, debt you have and so on. So it turns out to be a sticky problem in that it's not just, as you said, you can't always give an answer, but even when you can give an answer, it might not be in the same terminology that the person asking really wants. And so there's all this mapping that has to happen. So how important is this? I think it's important in the for debugging the system, it's incredibly important, right? And that's why a lot of attention is on that, because everyone wants to make their models better. And it gives a wrong answer. Why did it give a bad answer? In terms of the end user, they're going to care when the stakes are high, like the loan example. On the Paris example, maybe not, right? Or, some other kind of question. Tell me a joke and it wasn't funny. I'm not going to go and say, well, why did that happen? And so on, right? Let's just move on. So it needs to be for sort of, I would say, high stake decisions. And I think it's important because, one of the things that we are all experiencing now is going from not using these systems to using them more and more. And what's involved with that is a level of trust and how, can I trust that this is actually going to work? Like when I do a regular search now, in addition to getting web pages, I get I didn't ask for it, but Gen AI gives me a summary of what it thinks the answer is. And I started out saying, yeah, I'm not going to use that. I'm just going to go to the web page, the source, but it's now right in front. You can't avoid seeing it. And I'm starting to, use it maybe a little bit more. And is that a bad thing or a good thing, depending on how accurate it is, right? And do I actually go and check, so there's a, long answer, but I would say it's challenging. I think it needs to be there. Will people actually check the explanations? Sometimes when it really matters. So it's a question of, how high the stakes are.
Yeah, that totally makes sense to me. Yeah, in terms of going back to regulations, because I think this is super important. If you could wave a magic wand and have global regulation of AI that you believe would improve AI governance, what are kind of one or two things that would be on your wish list?
So caveat first that I am not a, lawyer, public policy, et cetera. I naively, when I first got exposed to regulations, I was actually shocked that they weren't specific. And then I spoke to someone who's familiar with how the world works in that space. And they said, of course, it's not specific because regulations takes a long time to create and they need to last for years, if not decades. So they have to be vague and open to interpretation of courts. All right. And that's different than the world I live in, which is more of a scientific world where I want a nice, crisp, well-defined problem statements, and then I can go and solve the problem. So that's the caveat there. I guess the most important thing I would say in terms of regulations is to understand how AI is actually built and deployed. And what I mean by that is quite often we have this perception that, okay, we're talking about regulating AI. That means, the model is something like, I mean model in terms of AI model. The framework is something like, OpenAI or Google with Gemini, where one person builds it, one person deploys it, and one person is running it, monitoring it, and so on. Right? So therefore, we're talking about how to regulate that. And certainly, those examples exist. But quite often, there are folks that will build the system. Maybe they'll put it in open source, like IBM has done, or they will, sell it, right, as a model. Here's a base model that you can use and embed in your software, right? So if I'm a, customer service system, customer relationship system, CRM, I'm not going to maybe necessarily invest in writing a base model. So I'll just license it from someone else, but I'll embed it in my system, in my software. Right? So now I'll sell my software to another company. And now the question of when I talk about regulation, who am I regulating here? Am I regulating that CRM company? Am I regulating the base model? And so on. And what are the requirements, right? Similarly, if I take a model and I put it on open source, I haven't deployed it, I just put it there so others can use, what kind of requirements are there on me? It's not a live model in some sense yet, right? So there's a really important distinction between the builder and the deployer, I think is important. And initially you didn't see that in regulations. I think now a lot of it has gotten, better on that, but you still see sort of some, what I feel, sloppy regulations. So that's just one thing, is just make sure you have that distinction, because there's different, aspects. Like, you can make the analogy to a car, right? I buy my car from, GM, right? But GM got the engine from some other company and who got the screws from some other company, right? Where's the liability there? Well, usually, if I'm a customer, it's who I interacted with. So it's probably on GM. But then you might say, well, okay, then GM should probably have strict requirements for their suppliers in terms of what they need to do. So it sort of indirectly pass on the regulations to them. And so I'd like to see that kind of thinking, that kind of framework be applied with any kind of regulations. And it's not easy. I'm making it sound easy in terms of what you actually require for the different places.
Yeah, I love the car analogy, right? Because the car manufacturer can make a car that they know is kind of sucky and is going to break down, and that's kind of on them, or is dangerous in some way. And they can also actively choose, hey, we're going to put airbags in here, or we're going to put anti-lock brakes in here, things like that, which obviously have happened over time and have made cars safer. But then no matter how safe the car, if you have an idiotic driver going 120 miles an hour on the highway while they're watching a movie on their phone, right, bad things are going to happen, right? So you're right. Separating those out is going to be super important for regulation. I still feel as if we're still not talking about, with cars, obviously there's a lot of risk to consumers and purchasers. And over time, the regulators effectively forced, as well as the insurance companies for that matter, airbags, anti-lock brakes, and all those safety features to go from a few very high-end cars to literally every car on the road. So that may be the longer-term analogy. And of course, that brings up the whole insurance question, right? So as we think about AI governance and models doing things that maybe people don't want them to, including erasing databases by accident, which happened a couple months ago, production databases, or revealing confidential or customer information, things like that. This is an absolute new field of insurance. And although most companies don't realize it, their cybersecurity policy probably isn't covering this, right? If your AI chatbot goes wild and sells cars for $1 or gives the wrong medical advice, like, you may be kind of on the hook for this in many cases. So how do you feel that insurance is going to intersect with AI governance over time?
Yeah, great question. And it's one I'm fascinated about, mostly because I don't know a lot about the industry, so I'm learning, so it's really exciting. So we actually had discussions with a company, a startup in Europe a few years ago that was looking at trying to do this insurance space. And the reason we were discussing with them was we had this model risk evaluation I mentioned earlier that was still in research. Now it's in product, which is a way of testing AI. And so the logical thing would be, if I'm going to insure an AI system, then hey, I probably should look at the AI system in some way and see what likely could go wrong, so I can set my premiums a certain way. And so things have, I'd say, evolved. There's a few companies popping up, but talking to the CEO of one of them recently, he mentioned that not yet a lot of, I would say, demand, because exactly the reason that you mentioned, which is companies, I think, believe their existing insurance will cover AI. And he mentioned there's a bunch of court cases that are pending. And as they get decided, to maybe what you had alluded to, is that, it's not going to cover, then people will start, looking for specific AI insurance. The fascinating thing to me, and talking to the CEO, was kind of the way he viewed the problem, right? So I'm coming at it from a very technical way and want to say, okay, look, if you're going to insure AI, you should certainly smell it and figure out how likely it is to go bad, so you adjust your premiums, right? So sort of the actuarially approach. What he was saying was, well, the insurance has a cap in some way, and I'm guessing this happens everywhere. We're new to this. So you say, well, how much insurance do you want? You want up to, let's say, 10 million? Fine. Okay. We'll give you insurance up to 10 million. And we're going to guess that maybe 10% of the ones we insure are going to go bad. So therefore your premium is, 10% of 10 million or whatever it works out to be per year. And so purely mathematical, just taking a guess at the 10%, And, it was interesting. And then I guess they adjust over time if the 10% is too high or too low. So it doesn't necessarily need, at least right now, the sort of technical aspect of trying to guess or precisely measure the likelihood of something, bad happen. As someone working in the field on the technical side, I was a little depressing to hear that. But that's kind of the way the world works is, we don't necessarily, if there's a need and a market opportunity, we don't wait for the technology necessarily to be there. If we can do it in, some other way and then adjust.
Yeah, that's a great point. I mean, I've been talking to a bunch of insurance companies about this as well and hearing the same thing. Not only that, but literally insurance policies, cyber insurance policies literally aren't even asking like, is your company using AI? It's literally not even on the questionnaire yet. Like that's how kind of slow it's moving. And I think insurance goes through different phases, and at some phase in the future, they're going to want detailed analysis about how companies are using AI to be able to differentiate between high risk companies, and low risk companies. And if you think about going back to the car analogy, right? Like, there's variable pricing for car insurance. Do you have a 16-year-old driver? Okay, we're going to charge you a lot of money. We know that's a high risk. Are you driving a super expensive car that costs a lot of money to fix? We're going to charge you more money, right? So I think that's going to happen, but it's going to take a lot of time for that to kind of play out, number one. And now think about all the new things insurance companies are doing, like, oh, if you let us put a camera in your car that's on all the time, we're going to charge you less money. So that's something that the driver has to choose, like, ooh, is this something I'm comfortable with or not? Is saving $100 a month worth literally having a camera in my car all the time? And if you're a cab company or Uber, like maybe you're going to require that of all your drivers, because it lowers your risk over time. So I want to go back to the whole.
Just to add to that.
Oh, sure. Fire away.
Yes, sure. Yeah. And in fact, before I was saying I was depressed because the technology is maybe not necessarily needed or used, you could easily make the analogy to what you just said is like, hey, I'll give you a discount if you run this model risk evaluation ahead of time, or I have these guardrails, you employ them. It's kind of like the camera, the runtime guardrails, checking for bad things and so on. Yeah,
that's a great idea. I actually have run that by various insurance companies, and they're so tightly regulated that right now, apparently that's not an option. So it may be in the future, or we may be able to figure out some way of doing it. But right now, strangely, to me and you being technologists, they're saying, we can't do that today, at least. So I want to go back to the stochastic nature of large language models and bring up a more specific example, which obviously we can generalize, which is that, right now, large language models are obviously operating on tokens, which are parts of words effectively or combinations of letters. And there's no concept within the LLMs, at least we're using today, in terms of what things are identical. So an example of that might be, Aleve is the same identical thing as naproxen sodium, right? There's literally a chemical that Aleve is, right? But if you say Aleve and naproxen sodium in different parts of a large language model as an input, it may not know or recognize that they're the same. And obviously there's some variations of those models which literally tag things as entities. Like naproxen sodium is an entity. It is equivalent to Aleve. And obviously we can generalize this to the entire pharmaceutical industry, and we can generalize this to conceptually to other businesses. So it's interesting to me that this kind of flavor of large language model is out there being used by all the major base model providers, yet there may be some pretty big advantage to high risk industries like healthcare companies and financial companies to having a slightly different version of a model where concepts can be locked down and identified in a singular manner. So I'm just curious, do you think that's something, so first of all, maybe a little background on that, and then where you think that might be going, and is this a path forward for certain industries to be able to create more governance, explainability, maybe even some transparency around what's going on?
Yeah, ironically, I'm working on exactly that problem the last few months. So the idea is what you said is to, what we, restating what you said is right now we give in a prompt or training data or just a bunch of characters. A tokenizer tries to figure out what are kind of words or sentences or paragraphs that are good groupings, right? So it may say, like in the happens so much, I'll treat that as one token. It may decide to break up words into separate tokens. So it gets a little complicated in terms of what the model actually sees when it's training. But your point is a really good one, is that there are these sort of higher level concepts that aren't really apparent in the text, however it's tokenized. Is there a way, like you say, for people who really care about this to annotate, let's say, or tag the text to talk about that higher level semantics? So like, for example, let's look at an email message, right? Here's an example. Email message. I'm going to use this as part of my training data. We know the email has a subject, a to, a date, and so on. And maybe if we can communicate that to the model, it would do a better job of when it has to generate a new email to know what dates look like, and not get confused that a date followed by the subject, they're different things and they shouldn't be concatenated in any way. So yes, absolutely. It's something that we're working on. We haven't yet put anything out publicly, but that will be soon. And it's part of, I'd say, a broader mission that we have we call it generative computing, right? And the idea there is really a simple idea, right? So for many years or many decades, the computer industry has been built on this concept of reliability, right? If you go back into the 1960s, we're building computer systems. We're going to automate some tasks. You can imagine the enterprises back then saying, hey, I don't know. Can I trust you? I've got these humans doing these things. Can I trust this? And we did a really good job, the industry, in both hardware, software, to make sure these systems were reliable for many, many decades, right? Including, dramatic changes to hardware, system software, programming languages, and so on. Reliability was always there, predictability. But now, as you said, we're in this age of probabilistic or stochastic processing, where we will ask a question and we'll get back something that may be different times, right? And so the idea of generative computing is to say, rather than fully embrace, right? So what you're seeing now with agents is you're saying, okay, I can ask an LLM for the capital of France and get back Paris, great. I can ask it to create a shopping list for me and sorted by the aisles in my grocery store, great. Why don't I just ask it to do the shopping for me? Talk to my vendor and just go and do it, right? And the switch you make there from a technical point of view is you're now asking it to do some kind of reasoning and control flow to say, okay, I need to, do this mapping, maybe I'm talking about if this happens, don't do that, and so on. And this is not something that LLMs, at least right now, are really good at. But we've got 50, 60 years of doing that very well in traditional programming language. So the idea of generative computing is to say, yes, embrace the power of these LLMs, but sort of treat them as a component. Use them when it makes sense, but when it makes more sense to do traditional computation, traditional programming, specify that and treat that sort of as a subroutine or a library call, and so on. And it kind of gets to the topic of sort of fault-tolerant computing, because now when you're calling that subroutine, you have to realize it's going to give you potentially a different answer every time, and you need to be able to handle that. So you have to sort of check for various kinds of conditions to continue in your application. And the generative computing idea that's been out last year. People can look for that on IBM research website. That general idea, the newer idea, what you asked about in terms of tagging, which I didn't say already. Yes, I think it's a very good idea. Is newer and will be coming out probably in a few months.
Yeah, super interesting. Yeah, there are definitely other companies doing this. I think Dominic Romano at DrainPipe.io has been looking at this, and specifically in the pharmaceutical industry. So, look, we talked a lot about AI governance. Tons of topics here. This has been amazing. Is there any kind of aspect of AI governance or risk management we haven't talked about that you want to close out on?
Sure. Just two things I wanted to mention. Earlier, we talked about sort of runtime detection of bad things in the prompt or in the response. IBM has this thing called Granite Guardian, which is open source. So, the listeners might be interested in that. And it's an example of a general model that can do those kinds of things. So I know earlier I mentioned a lot of products, but also Granite Guardian is something to certainly look into. And it's been ranked sort of number one in those kinds of models to be able to check inputs and outputs for various kinds of risks. The other thing I'll mention is a recent work collaboration with a really great PhD student at Notre Dame called benchmark cards. All right. So this is in the space of transparency. And the idea is, people really want to focus on benchmarking LLMs. We talked about it before in terms of evaluations. But quite often there's not a good description of what the goals of the various benchmarks are, right? You see this all the time. Everyone's measuring things, but what exactly is the benchmark measuring? And so collaborating with this student and my colleagues at IBM, we developed this sort of bunch of questions and then a lot of examples of documentation of benchmarks. And there's actually a call to benchmark creators to continue to do this documentation. She did I think about 1,000 or so already, just based on the existing sort of limited documentation and quite often a paper describing this. She generated these cards. And we're asking others to sort of, continue to do the same in terms of whenever there's a new benchmark coming out, can they document that? So this way, we can be using benchmarks correctly. When we want to evaluate risk or accuracy, we know which benchmark makes the most sense, because right now the state is not terribly good because the information is either scattered or not written down.
Yeah, that's awesome. Look, this has been great. A great deep dive on AI governance. Mike, thank you. Mike Hind, distinguished research staff member at IBM. Great to see you again, Mike.
Thank you. It's been a pleasure.
You are listening to the AI Risk Reward Podcast with your host, Alec Crawford. You can find us anywhere you listen to podcasts, for example, Apple Podcasts. Production and sound engineering by Troutman Street Audio. You can find them on LinkedIn. Please like, subscribe, and comment.